So the next one, we have vertical component. In the vertical component, we have two forces in the up. So what we have here, this other one will have T1 sine what? 60 plus, because two of them are the same plane. So we have then T2 sine 45 then equal to the other one we have here, that is a 50 Newton or T3 as the case may be. So now the first, this is our equation 2. So now what we do is to resolve. Looking at this equation, we can make T1 the subject of the formula of that equation. Doing that, what we have, T1 cos 60 degree is equal to T2 cos 45. So T1 will then be T2 cos 45 all over cos 60. So when we do this, let's see. So equilibrium of forces simply means that the force acting on a body are balanced, resulting in no net effect and no change in the object's motion. In the object's motion, the object motion is steady. There is no change in it. That means if just like when we talk about static equilibrium, we know we have two types of equilibrium: static and dynamic. In the static equilibrium, the body is not moving at all, but in dynamic, the body is moving, something like rotating at what? A constant angular velocity. In that case, we say is what? At dynamic equilibrium. But when it's at static equilibrium, the body is not moving at all. So this is the case. Now we have some conditions for what? Equilibrium. We have conditions for equilibrium. One of the conditions for equilibrium is that some of the horizontal forces must be equal to 0, some of the vertical forces must be equal to 0, and the moments at any point must be what? Equal to 0. So these are the basic things about equilibrium, and we are going to be looking at some calculations that has to do with very question that we are working with. So assuming we have a question like this, to find the tensions, this is the tension T1, T2, the T there. So in this first equation, to find the value of the tension, then if you look at the, find out that the two tension tends to be what? Equal. So to get this thing done, the first thing we do is to resolve the forces. This is just vertical force. This is going down, this one is going down, the rest is going up. So vertical and then opposite forces. So what it looks like, if you resolve the force, if you draw the force diagram, what we have is 40 Newton, here is tension, here is 60 degrees. So in this case, what we do, getting the vertical component of this force will give us, remember the position, this 60 adjacent to the angle, we have it as to be what? Cos. That should be cos. So that means T cos 60 will give us what? 40 Newton. But the tension we are looking at now is 2. That means 2T cos 60 will give us 40. Now cos 60 should be 0.5. Cos 60, 0.5. We have T times 0.5 equal to 40. Now 2 times 0.5 will give us 1 times T equal to 40. Then T is equal to 40 Newton. That means the two tensions here is going to be what? 40 Newton. So let's go to the next one, the next question that we have. The next question seems to be a bit different from what we have here. So the next one we have here, say that the first thing we do is also to resolve this. We'll draw the force diagram. If we are drawing the force diagram, what we have will be T2, T1, then the downward force W, which is 100 Newton. In the same way, this angle, I did not get it, let me change this. Okay, the angle is 60 degrees. So what we have here was 60 degrees. So getting the if I am to make a Cartesian plane around it to get the forces, the horizontal and vertical force. The horizontal force here is the horizontal force is T, and this other one we have it to be T2 is equal to, this is T1. I draw in, I don't know why I did all these things like this. Okay, this is T1. Alright, T1 is equal to T2 cos 60 degrees, because this angle is adjacent to that. So what next? Now the vertical component of this will give us T2 sine 60 equal to W, also equal to what? 100. So if it's that, so what do? We get the value of T. Okay, T2 will then be 100 over what? Sine 60. Sine 60, 100 over sine 60, that means 100 divided by sine 60. So what we have is equal to 115.5 Newton. Now we have this. Now this is our equation 1, and this other one is our equation 2. So coming to the equation 1, now we have T2. So we can substitute it for T2 in this first equation. So we have T1 is equal to T2 cos 60. So our T2 is now 115.5. Cos 60 will there be 0.5. Then what do we have? 0.5 times. So we have 5.8 Newton. So that's what we have in this case. So the next question, we're going to be looking at another question. So this is the next question we're going to be solving. We have this, we have to find a T1, T2, and then T3 is already there because it should be equal to this. So what do we do here? We make a force diagram of that. The forces, diagram of the forces, we have here to be angle 45. This other place will be angle 60 degrees. Here is T2, there is T1, and down here is what? T3, which is the same thing as what? 50 Newton. 50 Newton. So looking at this, getting this, resolving all these forces here. So we can see that this is alternate to this. We have it to be 45. This other one alternate to that, we have for 60 degrees here. So in that case, we are going to be resolving all these forces. So the first one we have, let's look at the vertical horizontal component. In the horizontal component of this force, we have T1 cos 60. Now because this angle, this horizontal is adjacent to that angle, so that's why it's cos 60. Then this other one also adjacent to the angle, we have it to be T2 cos 45, equation 1. So the next one we have vertical component. In the vertical component, we have two forces in the up. So what we have here, this other one we have T1 sine what? 60 plus, because two of them are the same plane. So we have then T2 sine 45 then equal to the other one we have here, that is the 50 Newton or T3 as the case may be. So now the first, this is our equation 2. So now what we do is to resolve. Looking at this equation, we can make T1 the subject of the formula of that equation. Doing that, what we have, T1 cos 60 degree is equal to T2 cos 45. So T1 will then be T2 cos 45 all over cos 60. So when we do this, let's see what we're going to get. So cos 45 divided by cos 60, we have, what we have will be equal to T1 is equal to 1.4142 T2. So with this one, we can now use this to substitute for this T1 here. T1 we have here. We use this against that. If we use it, what we have will be, that means we put this T1 there, what we have will be 1.4142 T times sine 60 plus what? T2 sine 45 equal to 50 or 50 Newton. So what we do here, sine 60 multiplied by 1.4142 will give us 1.2247 T2 plus what? That's sine 45. That will give us plus 0.7071 T2 equal to 50. So when we add these things together, we add them on 2247. What we have is 1.931 what? 8 T2 equal to what? 50. So now T2 will then be equal to 50 divided by 1.9318. So 50 divided by, we have, it will give us 25.9 newtons. That is what we have for the T2. We have the T2. So what next? The next thing is to get the value of T1. To get the value of T1, we're simply going to use this one because it's already there. What we are going to use, since we know that T1 is equal to 1.4412 T2, then we have our T2 to be this 25.9. Then T2, that means 1.4142 times 25.9. That will give us 25.9. 25.9 times what? 1.4142. So what we get is what? We have 36.6 Newton. That is where we are going to be stopping. And thank you so much for being part of the class. Share, like. If you are joining us for the first time, always remember to subscribe. Thank you.